Ronaldo is famous for his free kicks. He shoots the ball over the wall and makes it come down again to hit the goal. But how does he do this? Well, this has to do with an interesting physics phenomena called the Magnus effect.
When a ball moves through the air, the wind blows around the ball and comes back behind the ball. Right behind the ball you get turbulent air, and this causes a drag force slowing down the ball. This force is directly in the path of travel, so the only thing the ball will do is slow down. But when the ball is spinning, you get the Magnus effect. On one side the wind is traveling against the rotation, and the other side it's traveling with the rotation. The air that's traveling against the rotation will slow down due to drag, and the air that's traveling with the rotation will speed up. According to the Bernoulli effect, slow flowing air will have a high pressure and the fast flowing air will have a low pressure. This gives a pressure gradient, giving a force downward. Due to the rotation, the airflow at the top will leave the ball sooner and at an angle. The air has changed direction, and because of Newton's third law, there should be an opposite force in the other direction. The change in air direction and the turbulent airflow combine in the drag force. The radius of the curve is dependent on the radius and the structure of the object, the rotation speed and the forward velocity. The Bernoulli effect is the pressure difference you get between different airflow velocities. For example, if you blow over a piece of paper, the paper will move upwards. Another good example is an airplane wing. The distance the air has to travel over the wing is larger than the distance the air has to travel under the wing. It has to travel more distance in the same time. So the velocity on the wing is higher than the velocity below the wing. So the air on the wing has to accelerate. Because of this acceleration, the distance between the air particles gets larger. In summary, because the air has to travel a longer distance above the wing than under the wing, the velocity on the wing is larger than under the wing. Therefore, the density on the wing is smaller than under the wing. And therefore the pressure on top of the wing is smaller than below the wing, and this gives a pressure upwards. To show the Magnus effect, we shoot off a light cylinder. We roll it up to give it spin. When we release the cylinder, you can see the cylinder move upward because of the spin. And without spin, it just moves forward. The Magnus effect can be seen in all ball sports, such as soccer and baseball.
In this clip we can see the pitcher throwing the ball with the right speed and rotation so that it comes down at the point where the batter wants to hit the ball. Throwing like this increases the chances for the pitching team to win the game. And if you master the use of the Magnus effect, you can score beautiful goals like this one.